the late shift. It's a nice opportunity to get some reading done.
Speaking of reading, the Unicorns Book Club is meeting right now.
Oh yes, I'll have to keep their tea refilled.
Otherwise, it's a quiet evening.
Don't say that too loudly. Things tend to get weird when we use the Q word.
Oh, here's where I left my coat. There's a note.
What's it say?
This season of the Bug Hunters Café is made possible by Softerific and Mousepaw Media.
Bold news. Want to go watch the game?
Let's go.
You two are sure here late.
We're meeting someone for coffee.
Besides, it's never too late for coffee.
That's just because you don't have any caffeine in yours.
The best kind. Goes well with my ice cream too.
Who are you meeting this time? Another incredible, famous software engineer?
I'd say he's incredible.
And he's an author of a robust Python from O'Reilly Press. So that makes him famous to someone. Anyway.
Wait, you're meeting with Pat Viafore?
The one and only.
I think I will stick around. I haven't talked to Pat in a while.
You know him?
Sure. Pat, Jason, and I used to work together at Canonical, where I'm a software engineer.
Now Pat's a principal software engineer at Cloud Software Group.
First, that's awesome. Second, Jess, how do you find time to run a cafe too?
Time runs slower in Café, remember? I do my shift here during my 5-minute morning coffee break.
Oh, hey, there's Pat. He's signing books for the Unicorns Book Club. Hey, Pat, we're here.
Oh, hey guys. Oh, hey Jess, haven't seen you in a while. How's it all going?
Yeah, it's been a while. It's been going good. Thank you.
Yeah. How are you guys doing?
Oh, we're doing pretty good. Have a seat.
Well, thank you.
Hey, I guess I can get the orders today. I can get something for you this time, Jess, because you're always getting stuff for us. So, what would you like to drink?
Then I will get a Americano.
All right, Pat, what would you like?
I don't drink coffee. Is it awkward for me to be here if I don't drink coffee?
No, but
Maybe a water? Is that okay? I'm sorry.
we could do a water. Actually, we also have this really good coffee without any coffee.
That seems oxymoronic to me.
Yes.
No. Jason, you need to tell him the secret order from our menu. We have a coffee for people who don't like coffee.
Oh, now I'm intrigued.
Okay, you're going to have to jog my memory. How do you do that, Boyan? What's that called?
Ask the unicorn. It's the coffee for people who don't like coffee.
Do I just call the unicorn over? How does this work?
I can go get it for you.
Oh, okay. Thank you.
Yeah, I'll go get that. So yeah, it's Pat. It's amazing. It's like coffee, but it's not like coffee at all. I don't know how to describe it.
Sounds like a great thing for me to drink at a coffee shop when I don't like coffee. So let's go for it.
That works.
Yeah, you're gonna hate it and love it at the same time.
I'm not sure how to feel about that. You're not selling me there.
I'll bring a backup plan. Don't worry.
So, Jess,
Yes.
what's the most Pythonic way to make a coffee?
Pythonic way?
Yeah.
I don't know. What do you think?
I would just import coffee.
See? Pat is the expert Python here.
So what have you guys been up to? I haven't seen many of you in a long time.
Well, like usual, just working and going through Texas ice storm a few weeks ago. And it was amazing because my car just broken from the trees. But it's not that bad as when I was in South Dakota. So I like it here. How are you, Jason?
Hey, here's you guys' orders. Yeah, I've been having a lot of fun getting into building more stuff with Python. You know, I work at a consulting company, and so been working on an internal project. But I definitely discovering that I don't enjoy building things from scratch as much as I like fixing things that are broken. But I can do both. But it has been certainly fun getting to build a project from the ground up and make it as healthy and minimal on tech debt as possible. That's been interesting because it's a project where usually people are only working on it in between clients. So they've been like 2, 3, 4 weeks and then they got to bounce again. So you have to onboard it really quick. So it's got to be like really idiomatic Python throughout. Great DevOps processes and all that jazz. How about you, Pat?
Yeah, I'm a year into a new job. I'm working on virtualization, operating system and application virtualization. Sadly, I've moved away from Python. I'm in C++ right now, but I still run Python meetup in my spare time. But yeah, I'm mostly doing C++ code right now. Right now, I'm working on some actual telemetry engine for part of our code, which is fun.
Telemetry is a term that I keep hearing, and I'm sure I should know, but it's the term. I'm sure I know the concept, but as per usual with me, I know the concept, but I don't know the name. Could you define that?
Yeah, you definitely know the concept. And it's one of those things where like every company has a different definition for it too. So it's like DevOps or Agile. Everyone has a different definition. What I consider telemetry is instrumentation inside your project to give you insights about how it's operating. So it's more on the operational side. Some people think about, oh, am I getting crash reports or exceptions? But it can also be what features are used, what workflows do customers do more often, and that can help you make better decisions of, hey, should we go implement this feature? Nah, only 5 people out of 1 million use it. Let's not prioritize that right now. And so it gives you a much better idea of, should I be doing this? How is my product operating? Some people use it for more, how is my servers running? Memory, disk, network. So it can take on a lot of different forms. You'll see it in a lot of different ways. I like it because I'm a data-driven guy. Give me the data. And I want to base my decisions on data. So it's a huge help with that.
So that little box that says send anonymized telemetry data to insert software company here is actually a means of helping guide development for the features you're using.
You certainly hope so, right?
Wait a second. You're telling me you can collect data without selling it?
I can't speak to any one company. I hope we're not selling it. Yes, you can collect data without selling it. And I am a strong proponent of you should opt into it because let's be honest, GPDR is a thing we need to care about. So I'm a big fan of transparency with that. That's some of the things we're trying to focus on of how do we enable developers to not worry about things like GPDR or California Privacy Acts. And they just use it and they get those features for free. Like, oh, customer opts out, we don't send it.
I've been toying with the idea of some sort of telemetry thing in a testing framework that I'm trying to design on the side. The idea that you could run tests, like it builds the tests into the source code, and then you can get anonymized data on what's actually failing on particular hardware.
Kind of like a built-in self-test type thing.
Yeah, exactly. So if there's problems, then you can run the test suites diagnostically on the end user's machine, or they can run it without having to really do anything special. And then that can be collected and used to say, okay, well, this test is failing on this architecture and this is failing in this situation. And I imagine that might be particularly helpful. But yeah, one of the concerns I was having thinking about that possibility was, how do you protect that?
I think that's a good question to grapple with, right? Like, we should care about PII, personally identifiable information, and we should make sure that it's clear to the user, this is what we're collecting. Here's how we anonymize it, and let the user make sure they feel comfortable with it. Because some people are not going to, and we have to respect the decision. Scrub what you can, be very careful. One thing I always like thinking of is some people think, oh, this data is anonymized. But there's a phenomenon that's escaping me right now where if you have sparse data sets and it looks like I can't figure out any information from a single column, you might be able to link multiple columns together to figure out who that person is. Like if you just look at an age, you might not be able to tell, oh yeah, this is Pat. But if you say, oh, if I correlate this age with a location and a browser, maybe I can say, oh, this is more likely to be Pat. You have to think about that sort of stuff. You can't just say, oh yeah, I take out credit card numbers, we're safe. We have to think about, how do I look at every field of data and can they be combined to give an attacker who might steal your data a way of verifying who that person is?
Actually, that's a funny thing that you mentioned because I was helping screen anonymized stock proposals for a conference. and I came across a title and I went, wait, this looks familiar. And then I saw the domain of it and I saw some other piece of data and I went, that's Pat. I recognized you from it. And it never said your name or location on there. So yeah, I mean, I can definitely say that, yeah, anonymization doesn't necessarily mean that you can't figure it out. We're smart people.
Yeah, and what I typically tell people when looking at telemetry is don't take the data just as is. Maybe you can hash it so that there's no way of knowing who it was, but you still can group them or aggregate them together. Maybe there's ways to categorize them. Maybe you don't care about location, but you care about continent. Maybe making your data less specific can help anonymize it as well. So we have a tendency to just grab whatever we can, but really every data piece has to be thought of quite carefully.
So you're saying just collect what you need, not every single possible piece of data.
Yeah, I mean, you guys familiar with law of information theory, like signal to noise ratio and all of that? The more information you have, the tougher it's going to be to sift through all the noise and find the actual stuff. I hate looking through like log files that are a couple million lines long, looking for the one error. Like, that's why people invent things like Splunk to help with that. But really, there's like better patterns we should be doing when generating the data in the first place, not trying to fix it in post.
I'm remembering, actually, that was one of the things that we kept grappling with when we were all working together at Canonical, was we had all these different systems building all these different things, and sometimes it was really hard to figure out. Do you guys remember? Maybe Jess, you could tell me whether this is still going on. It can be tricky sometimes because we have to take information from 17 different sources and try and figure out what's failing, if anything's failing, and then of the things that are failing, which things are actually breaking, and how do we fix that? I know we can't go into a lot of detail, but on a broad level, like, is that still a puzzle, or has that kind of been solved?
I think there's no way it's gonna be solved. Actually, I mean, the more project is like going large, and it's not like what we can like avoid. So it's still, yeah. But like you said, like it's really hard to like find like where this like issues actually like came from. So it's still hard.
I'm getting more and more like, so Jason, you mentioned like that whole entire built-in self-test for things, and a lot of people think of that for hardware, but I want people to use that for more stuff. Like even your website, like give me a web page I as a developer can go to on my live system that just says, yep, everything's good. Think of like down detector or any of those, like what's available in AWS or GitHub, what services are down. Like dashboards can be super useful so that you're not, it's more of a aggregation pull model rather than I need to go trawl through everything. I actually have a good bug that I had to deal with once. You guys are going to love this. So this was, I think, my second year in my career. I was still a college student, and I was working for a small meteorology company. And we had a very haphazard approach to software engineering. I was the first person to bring in version control. Everyone would then come to me with the CDs of their source code to check in this version control. It was awful. But what happened is I was writing a web app, and it was awful. I did not write it well in retrospect, but at the time I thought it was good, like we all do, right? But the unfortunate thing about being a small company is customers have a direct line to your desk. So I would get customers calling me up that things are broken. I'm like, oh no, what's broken? Well, it turns out our database would migrate to a different column and rename it in production. We didn't have testing or staging or anything like that. So I'm like, well, I was never told this. Of course my stuff's broken. I built a whole entire web page that was a built-in self-test. It would go through every query that I could run, check that columns were there in the table, check that they were the right types. One time an int changed to a type to a string, I think, and that broke all my code. And I was writing very unmaintainable PHP code. So like I was struggling with my own code base. Like, is it my problem? I'd spend a few days and then go, oh no, the database is wrong. One time, well, many times that saved my skin, but one time everything was reporting green. All the columns were right, all the types were right, the tables were there, but customers saying no data's been updated in 2 months. Oh no, what's going on? Turns out our database moved from SQL Server to Postgres in production, and I was never told as a consumer of that database. Yeah, when you have a small company that's not a software company, sometimes some of those best practices get missed. So after that, I learned, oh, maybe I should have a built-in check of, was there data in the past 15 minutes?
Ooh, wow.
Built-in self-tests. We need more of them.
Well, and then actually remembering to run the tests too. I remember there was when I was working on that image testing framework that y'all use now, Jess. I remember I was just making a little change. I was just fixing some type hints. I figured, I'm just changing type hints. I don't need to worry about this.
There are no little changes.
So I skipped the commit hook because I think, it's just a small thing. It's the end of the day. I'm just going to go ahead and push this in. And next day, I've broken like 3 releases worth of tests. Like there's I failed the builds on like 3, and I'm like, okay, what happened? And I went back. In the process of changing the type hint, I had inadvertently switched a default true to a default false.
Oh no.
And broken, like I said, 3 entire builds. So I had to get that fixed and genuinely seek forgiveness from the guy who, Thomas, I think he's still there. He taught me so much about Get, and I'm like, I'm sorry, I think I broke. I didn't have the ability to restart the builds at that point. They're like, could you go kick those? Because I did something stupid. So we were able to get it green within like the first hour of my being back in the morning. But just that taught me to run the tests, because I've since passed this on to other people. That I'm a tech lead now, and it's like, no, you're going to run the test. So it's a small change. It doesn't matter. Run it anyway, because you never know when you've typoed some stupid mistake in there that could, create a bug.
Mm-hmm.
I found that if people aren't running tests, sometimes you also have to ask yourself, why aren't there tests? Like, are they easy? Are they hard to run? Do they take a long time to run? Do they not know about them? Anytime you have an escape, it's always worth looking at in like a blameless way, not you did something wrong, but it's a learning opportunity for a system designer. How can we avoid this in the future?
Yeah. And sometimes it's about educating, like running the test now is going to save you time later. It's like, but I'm taking, I remember was arguing with somebody one time. Well, he was arguing. He's like, why would I ever, waste time with these commit hooks? Like, it's just so much faster just to run it, just let the CI run it, and then I'll fix it later. I said, because the CI's got a turnaround time of about 5 hours. Your computer has a turnaround time of about 5 minutes. Would you like to wait 5 hours to know that your commit's broken?
Well, I do find it's always best way just to test it in production manually.
Please don't do that.
Is my drink chilled? Because I'm pretty sure I just felt a shiver run down my spine.
Oh my gosh. Testing in prod.
As bad as it sounds, I can come up with cases where that's useful, but that's like the 0.5% of the time. If you don't have a large customer base, or if it's not going to matter if you break them because it's experimental, I'm a little bit more okay with that. But as soon as you're like, nope, people are depending on this, they need this functionality. Yeah, I don't know. That's a problem.
But a large enough customer base is basically if you have a single person using your service, you don't want to break things for them.
Nope. You break them enough, they're not going to use your service anymore, and then you're down to 0.
Yep. So regarding the testing, I have one quick question. So recently I made one feature about our building process, and one of our team members just asked me, why don't you put some test about this new feature? Because we are not going to know what's going to happen. And I'm just like, yeah, sure. But the thing is how much should I cover for the testing?
The project that I'm working on right now, it's got a Python API backend and it's got a React front end. And the two are talking together. It's a fairly standard web application model. And what I have insisted on is 100% code coverage, asterisk. There are mechanisms for bypassing code coverage. You can say exclude this line, exclude this file, exclude this thing, but these are version tracked. My own personal approach to it is you should aim for effective 100% code coverage, but explicitly exclude the things that don't make sense. That way you have a documented decision of saying, let's not test this. This is not testable. I don't know how to test this. And because you have that documented decision, then if it turns out later, oh, that should have been tested, then you can weigh the reasons why it wasn't tested against the reasons you should test it. But the important thing is to avoid implicitly not testing things. Like explicitly not test is fine, but implicit skipping of tests is problematic in my opinion. And this has been interesting with the React front end, because like you're not going to have a hard battle talking Python engineers in 100% code coverage. React is another ball of wax altogether. And the practices that a lot of seniors in that field have is, well, just test this part here, or just test this section. Like, okay, just, we'll just fake the data coming in and then just test the end result. And where I pushed back on that was, well, the problem is that if you're just kind of sliding this mock data in somewhere in the process, what you are not confirming is A, that the data is getting all the way from the entry point you don't control, the API call, all the way to the front end. Like you have to make sure that what comes in the back actually comes out the front. But then you also, if something breaks, you don't want to be in the situation. And we've been in this with like what we tested at Canonical, where like something would break and we'd be sitting there going, what broke? Because there's like 19 different points of failure. And which one of those is it? And it takes us a lot longer. So if you can narrow those tests down and be able to say, this broke, this specific piece broke here, then you've saved yourself a lot of debugging time. That's my own personal philosophy. What's your take, Pat?
Yeah, that's interesting. I agree with everything you said. And then I'm going to twist it a little too, because that's, me, that's what I do.
Oh, yes.
In my view, every test answers a question. You may not think about it that way, but every test you write is, does some value exist in my system? You're confirming that you're delivering something valuable. And you have to ask yourself, do I care about that answer? If you don't care about that answer, don't write the test. I've written code that was used by people who they said, if this breaks, we don't care. Just fix it within the next month. And so it's like the test would have taken a day to run. We just manually spot checked it. It didn't change that often. The code that changed often that people care about, I tested everything about that because we cared about the value it protected. Is my system working is a question. Does my system perform under load is a question. But the other thing I want to add on is there's more than testing too. It's all about when something goes wrong, how quickly can you resolve it? And things are going to go wrong. We're human. Like that's just a natural part of software development, right? You don't want to find out when you're trying to shove a release through in an emergency. Maybe there's a security patch that you have to push out. You want to find out then that your code's broken. So the whole entire goal is how do I find out the earliest possible? And tests are one way of doing that, at least the unit tests that I think we're mostly talking about. You might want to say, does my data work end to end? Maybe I need an end-to-end test to answer that question. Or maybe you say, hey, how can I find out this information earlier? Maybe you, in addition to tests, you have, I'm going to go back to built-in self-test because that's a great idea. Maybe you have early failure conditions or at least warnings to say, hey, I'm in an inconsistent state. This is why you use assert statements in Python, right? You say, hey, I don't expect this to ever happen. If it does, we're in trouble. And that's a great way of catching things early. Now you have to pay attention to them. And now we get back to signal and noise ratio. It all comes full circle. But yeah, I think ask yourself, what question is my test answering? And do I care about that answer?
And then don't leave the answer, because this is a problem we ran into on the back in some of our early tests on the project I'm working on. Is we had units, we had 100% code coverage, but what I did not realize was going on, and this is the mea culpa. I was the tech lead. I should have noticed this, but what I did not notice was happening is that we were actually mocking out parts of our code. Like mocks are great. I love monkey patching. I love mocking. Those are amazing tools in testing. You should never be mocking out your own code, because what you wind up doing is breaking. It's like asking a leading question. And it's so easy to write a nice little test that it's a tautology. It's never going to fail because it's like, is 1-1? Like you're handing it, you start mocking out all the things. And what we discovered is that when we decided to start writing some tests that actually ran the whole gamut, that as we backed way up and we're still testing a unit. I want to be clear. We were still unit testing because we had tests that was like, we're only focusing on this one thing. It's just that we would assume, okay, when we test this unit, all the units behind it, we've already tested. So we're just assuming those work now, but we're not mocking them. The mock is still occurring at that very, very back, that call to the database. That's where the mock was actually occurring. When we started doing that, we discovered that the thing was fundamentally broken in ways that was manifesting in really weird ghost-like bugs on the front end. And we should have been testing that way sooner, but we had been doing these, we had been mocking out our own code and therefore kind of leading the question. So yeah, I like that, Pat. Think about what question you're asking, but then when you ask it, don't lead it.
Yeah, make sure you have an answer. Yeah, that's a great.
Actually, there was a tautology in the test suite that I was working on at Canonical 2. I remember going through and I was like, okay, cool. This is, what is this testing? Oh, it's mocking something. Oh, and it was literally mocking to produce the value 1. The mock was producing the value 1. And then the test was saying, is the return of this 1? This is never going to fail. This actually cannot fail.
You know what's, I want to do more of this, but I haven't been in the right project with it. You guys familiar with mutation testing?
Ooh.
For the Python people out there, check out MuttMutt. Really cool package. What mutation testing does, it's like a who watches the watchman situation. It goes and runs your test suite, sees what passes, and then it goes and modifies your code and sees if a test will fail. If a test doesn't fail, it says that's a mutant that has survived. You have it, like, it might change a true to a false. It might change integer division to float division. And it will keep rerunning your test suites, trying to find out, are your tests tautologies? Are they just always going to pass? Are you actually testing the piece of code that you care about? I haven't seen it used a lot in practice. I wish I saw it more. I think it's because most people don't have mature test suites. If you don't have a mature test suite, don't do mutation testing. It'll just be way too much noise. But if you have a well-tested library and want to say, does coverage actually mean anything in my project? Check out mutation testing. I once worked on, this was about 10 years ago, when the big unit testing push was really happening across the industry. And some people were being obstinate about it. And they were like, okay, we'll give you 100% line coverage. And these were their tests. It was create some foo, do something, assert foo is not none. All it was doing was checking that there was not a none after constructing it. They'd go execute every line and path because the action did something, but their assertions were meaningless.
That goes back to what Ned Batchelder was talking about when we were chatting with him about code coverage, because he's the guy who wrote coverage.py.
Yeah.
And he was talking about how, 100% code coverage it's not itself a bad thing, but it's a false assurance at times, because it doesn't mean that you've covered all of the use cases. It just means you've covered all of the code. Yeah. And like you just mentioned, there's ways around that. So, it's a beginning, but it's not the end.
So when I was writing Robust Python, I wanted a chapter on mutation testing. And I started thinking about, I wanted to call out that very specific thing. And the way I like expressing it is code coverage is a negative indicator. A low code coverage tells you something. You have a lack of confidence, robustness. High code coverage doesn't necessarily tell you much, just like you said. A low, so if I see 100% line coverage, I'm like, sure, that's a check mark. Great. If I see 5% code coverage, I'm going to be like, ooh, there's probably problems in this code. I think that's something a lot of people get wrong. We have this, everyone wants a metric to proxy business value. Oh, it used to be, number of bugs to be, caught or lines of code written. And now it's becoming coverage where people can game it just to make the business value look good when it's not a true proxy of is my code valuable. I've worked in enough places where I've had managers say, you have to give me 100% code coverage. And it didn't make our software better because no one was actually thinking about testability. They were just gaming the system, not maliciously, but just, I have to write unit tests, so I'll mock out my data or something like that. And they were not valuable tests.
They became TPS reports.
Pretty much.
I agree the plot was interesting, but I had trouble identifying with the main character's passion for artisanal hay. The difference in species might have something to do with it. Yes, Humans just can't appreciate hay in the same way. Excuse me, I have to get that. Bug Hunters Café, this is Annie. An order to go? Sure. What can I get started for you? 1 extra large Timothy Hay smoothie with oat sprinkles. Sure thing. No, Jean-Hide, you don't need to explain. Dietary preferences do tend to linger after you turn into something else, like a half sheep in your case. Reuven Lerner spent about 20 minutes as a matcha plant, and he still occasionally has a desire to photosynthesize. Yes, I'll have that ready for you. See you soon. I take back what I said. Some humans can appreciate hay.
The other question is, does testing work always take longer than making the new feature?
Yes and no.
Because so there's a new feature. I made a change like in 20 minutes, and to me it looks really, really great. And I started testing, and it just like took me like 2 days to finish the testing. So apparently that says to me like this new feature gonna touch like everything, almost everything. So I'm glad I checked that one. But just in my mind, there is some others. So okay, testing touches everything. So that means new feature gonna touch everything. But that everything does not mean they are always working. You know what I mean?
Yeah. My answer to you is yes and no. I talked about like test value. There's also test cost, right?
Mm-hmm.
How long does it take to write the test? How long does it take to run the test? How long does it take to maintain the test, which we don't talk about as much. We should talk about more. You want to maximize your value to cost ratio for tests. And you do that by either increasing the value. Will it catch more bugs? Will it give me more information? Does it answer my questions better? Or you do it by minimizing the cost. If it takes you 2 days to write a test, maybe you're testing too much. Maybe that code's not testable, and that's a sign of saying, "Oh, I don't really want to work in this." I talk a bit about extensibility a lot, and this is a key part. Like, is your code easy to change? If you're going to change it often, you should make that easy to change. So, that piece that you changed, Jess, is that code that's going to be changing, that has potential to change over the next 5 years, or do you think you're going to write it and never look at it again?
Oh.
So you have to ask yourself those questions. Like,
That's a great question.
if it's going to change a bunch, I don't want to spend 2 days every time I write that code to test it. I need to make it easier to test. We need to break this up into smaller pieces and maybe test those in isolation, and maybe just one big end-to-end test that covers that path. End-to-end tests aren't great for all the error conditions, but it's good to make sure that everything's wired up together.
And if I can add to that, in my experience, I would say yes and no as well, because in my experience, more often than not, the test always takes me twice as long as the code to write. 2 to 3 times as long. I mean, it just doesn't seem to matter what I'm working on. But I have to break it down a little further and say the test itself, the test logic itself takes me maybe half as long. The test logic is easy. And to your point, Pat, if the test logic is not easy, then you really should be, asking, did I even structure this right? All that. But the part that tends to really hurt, especially in more complex systems where you're dealing with like complicated data incoming, or like I know the sector you're talking about, Jess, and like that area, like there's 100 different places where we're pulling data from. Mm-hmm. And figuring out how do I mock that, I find it's usually the mocks that take me the longest, because I have to figure out how do I stop this from actually contacting a thing that's not going to be there, therefore making a brittle test, and inject in the data that I need to test with, either the right data or the wrong data, to make sure it's actually, breaking where it's supposed to break, handling different. But it's like coming up with the data you're going to put in is usually pretty easy. Writing the test logic is usually pretty easy. Actually figuring out how to mock that is not so easy.
Mm-hmm.
See, I see that as a code smell. Your dependencies are out of control. You have to. So you said you love monkey patching. I'm going to be antagonistic. You know how I like to be that, Jason.
Oh, yeah.
I don't like monkey patching. I see it as a code smell. Mocking, fantastic. Monkey patching, I see that as, I have a hard-coded dependency. Maybe I should be injecting that instead.
Well, and where I usually use monkey patching, I should add, is as a means of mocking out. The things I most often mock are either going to be file reads, database reads, API requests, or system calls. So like if there's another process that the code has to be able to call this other thing. I mean, we were working at Canonical, we were depending on those all the time. Like this other thing has to be installed, and it's going to return certain things depending on where it's running and who's running, yada yada. So those are usually the cases where I'm using monkey patch. Again, I don't like having to monkey patch my own code ever.
Oh, I agree with that.
Should never be monkey patching your own code. And secondarily is like you have to think about, like, if you are dealing with a third-party library. I worked on a data science project as well. It was analyzing microscopic slides, and really cool project, but there was a lot of machine learning involved. And there was also reading these massive gigabyte-sized images. And one of the first things I figured out in terms of writing the tests for this, and I got 100% code coverage on there, and that was able to prove long before we were able to run the whole thing, because we had to run it with real data on a graphics card, high HPC environment, high performance computing. But I was able to prove that it worked long before we got there because of these tests. But one of the things I did is I figured out, how do I write something that can produce an image? So what I was doing is I was actually creating an image in the format it was expecting. Well, not exactly an image. It was creating the data that was loaded from the image in the format that it was expecting, to where it could traverse it, but it was smaller, and I could actually specify, like, okay, the whole thing is black, make this one little square red. And then I could know, all right, when I'm reading this in, then this little thing's going to expect to be looking at just this section. So the entire section that it pulled in should be red. And if I read this larger section, then it should not all be red. So little things like that. That part took me longer than the actual code itself took me to write. But by doing that, I was able to write unit tests that I could test the entire thing without once having to actually hit a real image or hit the machine learning model at all. And yet I was able to prove all of the rest of the code worked. So by the time we actually brought the machine learning into the picture and ran the whole thing, it worked.
I think you're hitting on a really interesting point. And I think there's like a fallacy in what we're talking about. We're comparing how much time it takes to write tests versus how much time it takes to write the code. That's not what we should be comparing. It's how much effort do I do writing a test versus what does that give me in return. You got confidence with that machine learning project. You got answers, and you probably worked out some integration bugs. And well before the thing was ready, you probably shaved a few days, if not weeks, off of the schedule. Because if you waited until the actual production code was ready, you have to do that all afterwards. So yeah, it took you a long time to write. And the code may not have been an effort, but the amount of returns you got on that test, I would say, I think that's the comparison we should be making, rather than how much time did I spend writing the code. Because that's not, like, when we talk about like code's not that important. What it does is important. I can replace the code with something else. If it does the same thing, nobody cares. Business people don't care. It's the value that delivers. So we need to stop focusing on like what our pessimizations are, or what flows us down as developers, and focus on how we optimize value. That's how I kind of look at all of this.
Although I think there was some validity in at least people being able to know, oh, okay, it's taking me 3 times as long to write the test as it takes to write the code. That's okay. As long as the test you're writing is fine, that plan for that. Because, and this has come up with estimation too, in the project I'm working on right now. It's like, okay, so we use the quantified tasks technique of quantifiedtasks.org, if anyone's curious. It's a way of doing story pointing. So we have to answer 3 questions every time. Distance, friction, relativity. Distance is how long would it take me if I knew everything, relative to a sprint. Friction is what resources are there to be able to help me, or like the lack of resources. Friction 5 is there's nothing, you're on your own. Relativity is how many unknowns. And all of those are 1 to 5. So we figured those out in the same way you would do a normal story pointing. The story points actually are calculated from distance plus friction times relativity. And it works really well, covers the same range and the same relative scale as Fibonacci, but you can look back and see, why is this task big, which has been incredibly valuable for us. But in having that conversation about, especially distance, that question of, okay, if you knew everything, no surprises, how long would it take you roughly, relative to a sprint? And there have been a couple of times where, more than a couple of times, where the estimate was, it'd take me maybe a day. I could get this done in one sitting. And I would go, okay, great. Now add the tests in. And they would go, Oh, 3 days.
Now add documentation in. Now add security review in.
Yeah, exactly. Whatever your definition of done is, but like you have to remind them of that whole definition of done. It's not just the feature is there. It's you actually met your definition of done for the team. And it's like, oh, okay, no, that's actually going to take me 2 or 3 days. And it's good to know that up front. So it's good to remember that tests are expensive in terms of effort.
And if you find them being too expensive for your taste, ask your team and yourself, how do I make them less expensive? Is it that I have so many mocks that I have to create? Well, how about we do software engineering in our test code and like, hey, here's a repository of really well-tested mocks that we use across all of our tests. We can all reuse.
Like a certain library I built.
Yeah. Look, just because my ego is self-serving doesn't mean it's a bad idea, said every, narcissist ever. I jest. But yeah, we have to look at, like, I think it's okay for things to be expensive, but I think we can always be asking, can we do better? And no is an okay answer. We got it. I don't want to put in an effort to make this better because it may not be worth it. But that's not an excuse. That's a last resort. I think people treat that as the first resort. And we never say, like, how are we speeding things up for us and the future developers? Let's be honest. If it's slow for us right now, it's going to be even slower for the people 5 years from now who have no way of contacting us, the original authors of the code, after we've left and gone done who knows what, who knows where.
Speaking of authorship, you wrote a book.
I did. Yeah, I was handing it out and doing a little bit of signing for that unicorn over there. Is that unicorn always here?
Yeah. Sometimes there's more than one of them. And it's the same one.
This sounds like the whole not coffee and coffee thing again. It's breaking my...
Well, don't worry. The 7 unicorns you see over there are all different unicorns this time. But
yeah, I wrote a book. You wrote a book too. We actually, didn't you, Jason? Like, we had a little race at Canonical. Who would get ours published first?
Absolutely. I lost. But yeah, no, we were kind of comparing notes and woes and whatnot of like writing a book is hard.
It's super hard. I lost like every night for a year to that book. After work, after I put the kids to bed, it was just like, all right, let me sit down for an hour or two and just write. And I didn't understand writer's block before. And like, I knew of it. I knew that people were like, oh, I get stuck. But until you experience it, you're like, I need to write words on a page. The words are in my head. I don't know what to write. Oh, goodness. Like, and it's so frustrating. And this is just like, why can't I do this? I know this. And it was such a humbling experience for me. I don't know if that was the same for you. I was just trying to put your thoughts into text.
Oh, merciful heavens, yes. It took me 4 years to write the book. So it took me 2 years to actually write the book. It took me another 2 years to actually get the thing edited.
Oh, you have a weighty book too. That's 800 pages.
Yeah, nearly. Yeah, no, you could probably knock someone out with it.
Yeah, and I found it like high quality pages. It's not just fluff. Like, there was good information in there.
The fun thing about writing that was, and yeah, tell me if this is the same thing for you. For me, I went into it thinking, okay, I know some things, and I keep seeing these same questions, these same problems over and over. Someone should write a book. Might as well be me. So I started writing it. But as I got through the first third of the book, I started realizing I don't know this. So I would have to go and learn it, read the documentation, find some people who I routinely disagreed with and go, hey, could you please disagree with me? Like, do your thing. Like, here's what I think. Now shred it. And I literally picked the guys in IRC who fought with me the most. And like, here, could you edit my book? And they did. Very grateful to them. Yeah, it was. I did not understand the thing about concurrency or multiprocessing, had never used it, at least not in Python. I'd never needed it up to that point. And so I hit it and I went, I'm supposed to write an entire chapter, turned into 2 chapters on this topic I would know nothing about. So imagine so you get the combination of, I have to make up a reasonable example that is not, let's download a web page, because who does that? For asynchrony and concurrency, because every single async example online is, let's download a web page. I had to come up with something that wasn't that, write an example, and then through working the example and trying to write the material around it, literally learn asynchrony, threading, concurrency, parallelism from the documentation, and then make sure I'm capturing everything thankfully, one of my editors is a literal expert in threading, so he was able to tell me I actually got it right. But did you have that thing too, Pat, where it's like you got there, just went, I don't know what I thought I knew?
Well, no, but you shouldn't feel bad because I think our books are a little bit different in scope. Like I have given talks about the topics of my book. So my book's all about how do I write software that stands the test of time. And I specifically focus on code-based best practices, type annotations. How do you create types? And it's less reference but it's more opinionated. So me espousing opinions, like I'm full of those. I can do that. So I had a really good idea of what I wanted to write up front. I actually pitched the book first as a type, gain the most out of your type checker. And it was meant to be like a little 150-page mini book or something like that. And O'Reilly, the fantastic folks at O'Reilly, were like, this is a little narrow. Can you broaden it a little bit? And I'm like, sure. And I eventually said, like, okay, why am I worrying about type annotations? Well, I like them. People don't care about that. People want to write better code that finds more bugs. So I said, okay, I'll write a whole book about how to find bugs easy, how to make life easier for your maintainers, how to make life easier for people you'll never meet who are maintaining it years from now or decades from now. Yeah, code can live decades, and that scares me. But I wrote code 10 years ago, and it's still in production. And it's going to be in production for at least another 10 years, I hope. Yeah, if that doesn't scare you, like, it should. But I had a pretty good idea what I wanted to write. There were a few chapters where I talked about mutation testing. I also have a chapter on like some other Python libraries. I picked Pydantic for one chapter, Hypothesis, which is generative property-based testing.
I love Hypothesis.
Hypothesis is awesome. And I've used them before, but I didn't know all the details of like, what are all the cool features? How do I make this a compelling chapter? I think that's what you were kind of like, yeah, I can talk about this, but downloading a website may not be that compelling for someone who's read 10 different tutorials online. Mm-hmm. So trying to craft a compelling example that showcased what I thought was really neat about that was hard. I think that's probably the closest I can draw as a parallel to what you just described.
Yeah. Examples are rough.
All my examples are food-based because I love food. Like, at least 3 chapters have pizza as the main theme. I pitched it to another publisher before I went to O'Reilly, and they're like, your writing style is okay, but can you lose the food examples? I'm like, but those are fun. Everybody knows. They wanted something a little bit more real-worldy with like, write a Twitter bot or something like that. And it was like, not everyone's going to be a web dev or an API person. I want embedded people to read this. I want new grads to read this. I want experienced people to read this. I'm like, I pretty much just created Automated Kitchen where I said, okay, if I wanted to make an automated kitchen robot, what would some of that code look like? And then just pulled excerpts to demonstrate examples. Some people love it. And I've had some reviewers tell me like, this is stupid. And I'm like, yeah, it is, but I love it. So it's staying. Some people have liked it. They're like, yeah, the food examples were fun. Just don't read it, 3 hours after dinner. You'll be hungry. I've been curious about your book, Jason. Like, how daunting was it looking at the scope of what you wanted to write and be like, like to me, I wanted a short focus. Mm-hmm. And when I was like, I'm approaching 300 pages. Oh, this is so much. How do you do this? Like, I salute you looking at your book. It boggles my mind.
Well, it helps to lie to yourself. That's the big part, is lie to yourself. Self-deception works wonders. Anyway, I never really owned the fact that I was writing a book that big. I was just like, okay, I'm just going to cover these topics. And I gave myself to the delusion that it was going to be easy, because it's the same way. This is going to seem like a tangent, but it's the same way that I managed to carry 40 computer towers from upstairs in a house to a downstairs. It's like just 3 at a time. It's like, oh, gosh, you imagine doing that. And it's like, like makes you not want to help the person move. And anyway, it was just what I got through it the same way. I just lied to myself, like, this is the last one. And then I'd get back to the staircase, okay, one more, only one more. And then I'll give up. And then I kept doing that for the entire thing. Just one more, just one. So, but when I started writing this, basically, I was just going section by section. I just thought, okay, I'll just do this section. I'll just write this section. The next one will be easy. I'll let myself pretend. And then from there, I just went one at a time. until I realized about 3/4 of the way through that I had hit almost everything in the glossary for the Python documentation. And it was like, oh, I'm only missing 5 things. Let me go back and put those 5 things in. And by that point, I had the entire core language covered.
It's impressive. Like, looking through that, I was very impressed. Nice job.
Well, thank you. I guess that means that you could almost say that we're sort of unintentional companion books. Because I touch a little bit on testing. I go into PyTest in some depth and how to actually use it, but we're almost companion books because it's like Dead Simple Python will teach you how to write it, and then Robust Python will teach you how to write it where you're not going to hate yourself after the fact.
The why you write it.
Yeah.
Yeah, I see them both in that kind of that intermediate programmer niche. Like, I would love for people new to programming to read my book. It was targeted more towards intermediate. It's still valuable when you're first getting out, but I'm trying to draw on lessons learned after you've been in the game for a few years. And I think those sort of, like your book too, it's good for a beginner reference, but I think the intermediate programmers are going to get the most out of it because it's that deeper dive. They want to level up. They want to go learn the next thing.
Exactly. And I think we need more, not just in Python, but I think across the board, we need more intermediate books because a lot of tech books, I've talked about this a lot of times, that you have books that most books out there are either, here's how to code for the very first time. Let me explain variables, boys and girls. Variables like a box with a name on it. And then you have the, today we are going to be building a natural language processing model on a Raspberry Pi running on a potato battery in your grandmother's basement.
Yeah, the hyper specific.
And there's nothing in between. A lot of times within a specific space. And I think we're seeing a lot more of these books like yours and like mine and, Manning and No Starch Press and O'Reilly have really been putting out a lot more of these sort of general purpose, but intermediate books. Is like, here's some practical things that you can actually do with your language or with your stack to make your code better. And I think we definitely need more of those.
I had a reviewer tell me, this book could have just been a series of blog posts. And I was like, well, yeah, but no one reads my blog. I bet you I can get more people to show up to the book. But it was that same sort of thing. Like, yeah, the blog posts are just how to do this. And I wanted to go more into the, why are we doing this? Like, why do we read tech books? Why instead of blog posts or Googling? And I want a curated experience as someone to lead me through a topic. I'm not going to even know the right questions to ask. So I want to look through a book and someone is curating that guided tour for me. Where I can't get that if I'm just Googling or, just reading blog posts. It's just, it's what I'm interested in. I'm never going to know about the things I don't know.
Right.
And that's where I think those books are fantastic. I would love to see more intermediate and advanced books.
Yeah. And it's not going to suddenly disappear off your shelf because, somebody's web server went down.
Because ChatGPT finally killed Google.
Well, I mean, blogs die all the time, like, Stack Overflow. Oh, this, you're reading through that feeling of like, oh, finally, this is the exact problem I'm having. There's a comment that says, oh, I had the exact problem. Go here, take a look at my blog post. And you click on it, and it's a dead link. And it's just kind of a Denver coder, situation. It's like,
what was the answer, Denver coder?
What did you see? The worst problems for me are the hyper-specific ones. The ones that are just like so, like, because then it's like, well, have you looked it up? It's like, I don't even know that anybody has ever used this in this manner before. I think I'm probably the first. So I'm basically trying to figure out how to repair this one-of-a-kind piece of code in a situation that no one's ever been. I'm on my own. There is no help.
Yeah. When I look at hyper-specific resources, generally it's not because this is what I want to go solve. It's just too specific, but it's more of, how did you wire these things together? What enabled you to do that? And but you have to dig in a little bit further than what the author is trying to say, because that's not their intention. They want to show, here's how you solve this problem. If you don't have to solve that problem, you got to dig. Just be like, okay, why do you solve the problem this way? Are there patterns that I can apply and things of that nature?
Exactly. Jess, I don't think I've ever gotten to ask you this question before. What is the weirdest bug you've ever encountered, or one of them?
Well, almost everything, every bug is so weird to me. It's hard to pick. I don't know. I couldn't think of it. Do you have some specific case you think of it?
I don't know. Bugs show up everywhere.
Yeah. It's
Just
true.
you're going along and you expect it to work, and suddenly it's like, well, it's failing, and this is not a normal failure. This isn't like I forgot a semicolon. This is just
Yeah.
This is
just
the
behaving.
I'm looking at this for 2 weeks and I still don't know why it's broken. And then you fix it and you go 2 weeks more. I don't know why that fixed it.
Yeah, I hate those.
Exactly.
Yeah, they're traumatic. We put them out of our mind, I think, a lot of times. Well, I remember, talking about the cloud images. I was thinking this earlier when we were talking about the tests. Is like the other nice thing about having tests is you can also know it's not your fault. Sometimes you've got good tests, because I remember like we got reports that AWS had, this is, remember December 2021, the nightmare year for the cloud, like AWS went down like 3 times. And one of our coworkers at Canonical, his girlfriend actually calls him. She goes, "Netflix is down. What did you do?" He's like, "No, this time I can guarantee it was not me." It's like, because I remember I was there. Like we were all scrambling. Like, did we break something? And no, we didn't. We were good. But tests were great at that moment because it gave us the assurance that this wasn't us. The AWS, somebody tripped over a cable at AWS. This is not our issue. That can sometimes be really comforting to know that because software is highly integrated. We're most of the time when we build a piece of software, we're building a piece that fits into this larger jigsaw puzzle over which we have no context. And we just want to make sure that we're not breaking everything.
Yeah, that saved my bacon on another different cloud I was working on. I was working at Canonical. I think it was before either of you joined. But there was a problem in one of the major clouds. It wasn't AWS, it was another one. And they're like, you need to roll back your images. They're broken. And we were sitting there going, what do you mean? They're like, it's causing service disruptions everywhere. And we looked at our tests, and our tests were still passing. Our images were usable. It turned out a certain subset of people who just depended on very specific functionality couldn't use that functionality. But because we had tests to show this works, we were able to talk them down and say, we don't need to treat this like a priority one. Like, your customers are down. We have workarounds to go fix that. But we don't want to go break every other customer by pulling an image. Millions of people are probably working just fine. Like, we have to be careful when we fix a bug that we don't be too rash and say, oh, I fixed this bug, I rolled it back, and then destroy things that people are depending on that since you've released.
Actually, remember, I was in that meeting, actually. I was.
You were?
There.
Okay, you were there.
I was in that meeting.
I couldn't remember if it was pre-Jason or post-Jason. But yeah, you remember, it's like, why we can't just roll back things willy-nilly. Like, there's consequences to that. We might break more people in doing so.
Yeah. The bug fixes can sometimes be as dangerous as and you have to think, is the cure worse than the disease?
And no kidding.
But I definitely like being in consulting now. It's a little bit less high stress because it's like, cool, if I make a mistake, it'll just break the CI, not the internet.
We were talking about weird bugs. I got a fun weird bug for you. This was back in the beginning of my career. I was working on embedded C++ at the time. And it was my first year into this job. I had only been a software engineer for like 2 or 3 years prior. So I was still relatively green on a lot of things. And I was told, hey, we have this product that needs to be migrated to a new system over, like, you have a year to do it. We don't have anyone else to look at it. This is a great chance for you to jump in. And I was like, what? Wide-eyed, like, what do I do? I was moving some internal communication between, so it was a system where there were multiple cards that went into a chassis and they all talked to each other. And I was working on one of those cards. And I had to migrate to a new communication style because that's the architecture we were moving towards. And I was making my changes, and we're talking tens of thousands of lines of code over months and months. And we didn't have CI at the time. This was early 2010s. So we weren't as mature as we would later be. So we didn't have great CI. We didn't have good tests. Our testing was manual. And no one cared enough about the product right now. Cared about it a year. So that we couldn't spare testing resources. Well, I broke something and it wouldn't even get past the boot up stage. I couldn't do print debugging because it's embedded. The printing system wasn't set up yet. So I couldn't even get any print debugging. I'm like, well, I know nothing else. But, oh, wait, no, I remember. I have a debugger. pull up a debugger, problem doesn't happen. It's a Heisenberg bug.
Oh, no.
The debugger changed the timing and memory allocations enough that I couldn't find it. What I ended up doing was bisecting my code. I would look, I'm like, I know it's in this part of startup code. And we're talking like 100 files, thousands and thousands of C and C++ code that's all mangled. And I just would rip out half of the code and say, does the bug still happen? Okay, it does. I rip out half of the remaining code. Like I would be deleting out code or commenting out code. But then it turns out, well, if I commented out too much, it wouldn't even boot because like part of it was like boot up stuff. And it's like, oh, it would just go in a constant reboot. Like, well, I can't take out too much. So it's this like fine thing of just bisecting my code. I can't use print statements. Debuggers, no help. But a compile takes 10 minutes. It's a custom compiler for custom hardware, real-time operating system sort of stuff, and it took me 2 weeks. And finally, I found a function called get event data. I'm like, well, that's just getting something. It's not like doing it. I just skipped over it. Finally, I commented out that one line, and everything works. Oh, get event data is actually setting event data, and I'm overflowing a bus. And like, just it taught me such a valuable lesson of like, oh, even though something's named something, like don't take it for granted. Like you don't want to be surprised when you're looking at code. Oh, this get function is actually a set function and I'm passing invalid data to it. And I was writing like, this is a thing that had like kilobytes of RAM. And I was writing like a whole entire like database table to a string out to its memory, just completely overflowing any buffer and trashing everything.
Oh, man.
Oh, it was so miserable, but I learned so much. I love bugs because you learn the most about a system when you're digging deep. That's probably the worst bug I've had to deal with. And a lot of it had to do with inexperience, but it was awful.
Well, I feel validated now. I did that last week. I mean, not the bootloader, but I actually had a bug that was the same sort of thing, only the database wasn't willing to do anything. Like I was having a problem with the database, and I had to do the same thing. I was like commenting out, like a comment of this half, no, this half, no, how about this and this and this, and you know, finally got it done. Like, okay, it's just this one line.
Yep.
Yeah.
Dealing with like corruption bugs are awful because when it happens, it might be seconds after where the bug was introduced, thousands of lines later. You corrupted memory one place, and it kept chugging along until it reused that memory. Boom, crash.
Actually, that's right. Mine wasn't database. Mine was actually Black fighting with itself.
Oh, wonderful.
The Black Python auto formatter was fighting with itself, and I had to, so it was failing on the linter, but only that. Turns out, by the way, spoiler on that, turns out that my virtual environment had 2 versions older version of Black that was running in Tox, because Tox, of course, gets it every time. And so there was a change in how Black worked, and so it was fighting with itself. Once I updated Black, everything was fine. That was, same sort of thing. You can't, one of those situations where you can't use print statements. You just have to start commenting out code and seeing where is it at. Well, this was fun, you guys. Pat, how was your non-coffee?
Oh, it's delicious. I actually am quite surprised with how I was thinking it'd be awful. Like, I still kind of hate it, but I think I love it more. So you did well.
Love being in a cafe with impossibilities.
Oh, it was good talking to you guys. I enjoyed seeing you again. But it was nice meeting you. This is our first time. Pleasure sitting down and chatting with you.
It was a pleasure meeting you as well.
Yeah, it was really good to see you again, Pat. And it's super fun to talk with everybody about testing because it's really rare to talk about like this much deep. So I learned a lot from here. So thank you.
You are all wonderful people.
Absolutely.
Bug Hunters Café, this is Annie. Sure, we're open 24/7 at bughunters.cafe. You can also find us on LinkedIn and on Mastodon as Bug Hunters Cafe at hackyderp.io. Oh yes, the music is provided by Audionautics. We have a link on our website. You're welcome. Bye-bye. You need another refill on that peppermint tea? Sure, By the way, I loved your observation about the antagonist's motivations. Very compelling. No, I can't say that I've ever had a desire to graze on someone else's lawn. I've never even wanted to graze on my own lawn. Well, I imagine you've never desired to play guitar. You have? Well, I've learned something new.